Hello everyone, I am Harshita KM from Sri Venkateswara College of Engineering, currently studying in 6th SEM from Department of Computer Science and Engineering. Today I am going to present the topic on solar photovoltaic system with its applications, and then next moving to contents part. The contents include introduction, system work, system components and photovoltaic applications. Moving to introduction part, a photovoltaic system is composed of one or more solar panels combined with an inverter and other electrical and mechanical hardware that use energy from the sun to generate electricity. Photovoltaic systems can vary greatly in size from small rooftop or portable systems to massive utility scale generation plants. Although photovoltaic systems can operate by themselves as off-grid photovoltaic systems, this article focuses on systems connected to the utility grid or grid tied to photovoltaic systems. And then coming to system work part, the light from the sun, made up of packets of energy called photons, falls onto a solar panel and creates an electrical current through a process called the photovoltaic effect. Each panel produces a relatively small amount of energy but can be linked together with other panels to produce higher amounts of energy as solar array. The electricity produced from a solar panel is in the form of direct current, although many electronic devices use direct electricity, including phone or laptop. They are designed to operate using the electrical utility grid, which provides alternating current. Therefore, in order for the solar electricity to be useful, it must first be converted from direct current to alternating current using an inverter. This alternating electricity from the inverter can be then used to power electronics locally or be sent to the electrical grid for the elsewhere. And then coming to system components, this photovoltaic system consists of many components. The major components include solar panel. A solar panel consists of many solar cells with semiconductor properties encapsulated within a material to protect it from the environment. These properties enable the cell to capture light, or more specifically the photons from the sun, and then convert their energy into useful electricity through a process called the photovoltaic effect. On either side of the semiconductor is a layer of conducting material which collects the electricity produced. The illuminated side of the panel also contains an anti-reflection coating to minimize the losses due to reflection. The majority of solar panels produced worldwide are made from crystalline silicon, which has a theoretical efficiency limit of 33% for converting the sun's energy into electricity. Many other semiconductor materials and solar cell technologies have been developed that operate at higher efficiencies, but these come with a higher cost to manufacture. And then next, covering the important component of photovoltaic system is inverters. An inverter is an electrical device which accepts electrical current in the form of direct current and converts it to an alternating current. For solar energy systems, this means the direct current from the solar array is fed through an inverter which converts it to alternating current. This conversion is necessary to operate most electric devices or interface with the electrical grid. And then moving to application part, the photovoltaic system consists of many applications. The few major applications include solar farms, remote locations, standalone power, power in space, building related needs, military uses, transportation. And then next moving to solar farm part, many acres of PV panels can provide utility scale power from tens of megawatts to more than a gigawatt of electricity. These large systems using fixed or sun tracking panels feed power into municipal or regional grids. Then coming to remote locations, it is always not cost effective, convenient or even possible to extend power lines to locations where electricity is needed. Photovoltaic can be the solution for rural homes, villages in the developing nations, lighthouses, offshore oil platforms, desalination plants, and remote health clinics. Then covering the standalone power part includes in urban or remote areas, the photovoltaic can power stand-alone devices, tools and meters. Photovoltaic can meet the need for electricity for parking meters, temporary traffic signs, emergency phones, radio transmitters, water irrigation pumps, stream flow gauges, remote guard posts, lightning for roadways, and more. And then next moving to power in space part. From the beginning, PV has been a primary power source for Earth orbiting satellites. High efficiency photovoltaic has supplied power for ventures such as International Space Station and surface rovers on the moons and Mars, and it will continue to be an integral part of space and planetary exploration. Building related needs. In buildings, photovoltaic panels mounted on roofs or ground can supply electricity. Photovoltaic material can also be integrated into a building structure as windows, roof tiles, or cladding to serve a dual purpose. In addition, awnings and parking structures can be covered with photovoltaic to provide shading and power. Coming to military uses part, lightweight, flexible, thin film photovoltaic can serve application in which portability or ruggedness are critical. Soldiers can carry lightweight photovoltaic for charging electronic equipment in the field or a remote base. At last, covering the transportation part, photovoltaic can provide auxiliary power for vehicles such as cars and boats. Automobile sunroofs can include photovoltaic for onboard power needs or trickle charging batteries. Lightweight photovoltaic can also conform to a shape of airplane wings to help power high altitude aircraft.